Good morning, good afternoon, good evening from whichever location you are watching this video. A very warm welcome to Questpoint's channel. And what are we doing in this video? In this video, we'll be learning AI ML, artificial intelligence and machine learning using C#, Python and Azure AI. So if you are a C# developer, right, then you have come to the right place, you have come to the right video. I can guarantee that if you watch this 1 hour of video, which has approximately 10 lessons, which I'm flashing on the screen. In that 10 lessons, 7 are theory and 3 are practical hands-on labs. If you watch this much, right, your AI ML journey with C# and Python and Azure AI gets started. Now, before we start with these lessons, right, I'm sure that there are two questions, which are generally asked by C# developers who enter into the AI ML thing. First one is, do I have to learn Python? The second one is the roadmap for C# developers for AI ML. Both of these answers, right, I can only answer if you understand what is termed as a model. So what I would suggest is that until we don't complete the 9 lessons, let's not talk about it. On the 10th lesson, if you watch the syllabus at this moment, which I'm flashing on the screen, the 10th lesson is where I will talk about the roadmap for AI ML for C# developers, right? So till then, please hold your horses, right? I understand that, because if I give a roadmap now, right, it would become very difficult. I have to explain you what is inference, I have to explain you what is model, I have to explain you what is training, right? So I would suggest that just wait for at least 9 lessons, and then on the 10th lesson, you will get a complete idea of how things are. So before we proceed, right, here's a small gift for people who have come to this lessons out here, right? So if you go and if you share this video on your LinkedIn, and if you tag me on my LinkedIn, right, saying that, the lessons were good or whatever you feel, right, I will give you this ebook. You can see that this is a small ebook out here, and this ebook with the labs will help you to expedite your learning. So for example, what is AI ML? Small one-liners out here, explain features, labels and models. You can see what is a pipeline, what is CUDA, what is ML.NET, right? So what happens is that one is that you are seeing the theory, one is that you are seeing the labs, right? And another one is that these notes will expedite in that learning process and in the revision process. Let us quickly run through the syllabus. So you can see that I am flashing the syllabus on the screen. So remember that this is completely a 1 hour of lesson, and you can see that 1 hour of complete tutorial what we have here. And you can see that there is lesson 1, lesson 2, lesson 3, like this. We have 10 lessons. So now some of the lessons are theory and some of the lessons are labs. So you can see that we have approximately 3 labs out here. And we have 1, 2, 3, 4, 5, 6, 7 theory lessons out here, right? So what we'll do first is that we'll first start with the theory part. Many developers think that AI and ML are one thing, so we'll first talk about that. Later on, till the lesson 3, I want to talk about 4 or 5 things out there: features, labels, algorithm, training and model, right? So this is the lab, lesson 3, very important lab out there. And then theory out there, I'm sorry. And then lesson 4 is a lab. So what I'm thinking out here is that rather than first going and writing the code in C#, right, how about first we go ahead and we use simple Excel and we understand things out there, right? Then we will go and we'll talk about what is the difference between algorithm versus the model. Then we will look into regression, which is the very basic algorithm out there. So we will look into a simple linear regression. We'll execute a small lab out here where we will take in a data out there and we will try to predict simple linear regression by using ML.NET, by using MLContext and MKL components. And then later on, I also want to convince you guys that the model what you see out there is a mathematical formula. So that's going to be lesson 8, and lesson 9 we will talk about inference versus training. And after the 9th lesson, when you understand the difference between the inference versus the training and what exactly is a model, right, then we will talk about the roadmap for AI ML for C# developers. Also, I will answer that question out there, that does a C# developer have to learn heavy Python when it comes to AI ML? So for now, first thing, let us get started with lesson 1, which is a theory. What is the difference between AI and ML? What is AI and ML? Now I'm coming up with a free C# AI ML with Python and Azure training out there. So this free training, what you can do is that you can get registered on this link out here, right? And it is ai.questpoint.com, where you can go ahead, it's a free registration, no money asked, nothing, right? And this training will happen on the Zoom link. So we have very, very limited seats, right? So go ahead and get registered for this training. And in this training, in this 1 hour, 1001%, you will get to know what is the roadmap of C# and AI ML, how to do it, right? How does Python add value? Also, I'll be going through a lot of other topics also, like how does Azure AI add value, right? So go ahead and you can be in touch in this live training from the Zoom link. Many developers think that AI and ML are one and the same thing. Even when developers spell these words, they will say AI ML. But remember that both of them are two different things. AI stands for artificial intelligence, ML stands for machine learning. One is the main category, the AI is the main category, and ML is a subcategory which implements AI, right? So when we say AI means what? AI means it's a broader field. It's a broader field, where humans want computers should think like humans. Your robot or your machine should think, act, sense like humans. Now there are various ways of implementing AI. So developers attempted various ways. For example, writing an if condition. If it is hot, then the robot will take a shower, right, or something. Okay, so if conditions, definitely not scalable, but one of the ways of doing it. Fuzzy logic, why not? That is one of the ways of doing it. Or driving from the database, one of the ways of doing it, and so on, right? But the best way or the proven way of implementing AI is machine learning. Machine learning implements AI by teaching machines by using data. So in other words, you feed the data in and the machines will learn from the data. Now when you change this data out here, the machine will automatically learn from the changed data. It will improvise, it will update, it will become smarter accordingly by the data what you provide, right? And the most important part of machine learning is that you should be doing all of this without programming changes. So if you want to go and change, how the machine is thinking, right, you are going to go and change your data and upload it back. So this is the most important part, the last line, without programming changes, only by data, you will be training the machines. So fine, our dream is that we want that machines to think like humans, right? And for that, we are talking about machine learning by using data, right? But now let us take a pause back and try to understand that how do humans learn? As a kid, how do I learn, right? So if you look at any kid out there or even an adult, right, he gets trained by using features and labels. So for example, here are some examples of features and labels. Red, round and sweet, apple. Yellow, oval, sweet, mango. Yellow, long, sweet, banana, right? So if you see the first three things out here are features, right? They describe the characteristic of that object or describe the characteristic of that entity. And the last one is what we learn from it. So you can also think about from the other way. The first three are the inputs. So if I train a machine that how to identify a fruit, and if I tell me what is red, sweet and round, he should tell me it is apple, right? So whenever you are training a machine, right, the data format has to be in features and labels, features and labels. So you hammer the machine, with large amount of data, which is having a structure of feature label, feature label, feature label, and then the machine learns. So features are inputs and labels are outputs. Now, when you are giving this features and labels to the machine out there, as a developer, you have to choose something called as an algorithm. For example, in this case, yes, we are putting all these three inputs and we are getting that one output, which is the actual fruit. So must be I will choose a decision making algorithm, because he will say, okay, if sweet, if this, if that, then it is apple and so on, right? So decision tree algorithm. So the second thing is, when you're feeding these features and labels data into your machine, and when you're training your machine, you should also choose an algorithm. And then both of them, so features and labels, right, and the algorithm, when they get trained, so when you give him the features and labels and say that this is the algorithm and you train the machine, the output which comes out is termed as a model. I repeat this. the output which comes out is termed as a model. So features and labels, and at the other end you have the algorithm. You feed that into your training system, and the training system gives out a model, and this model is that brain. So if you're asking that, okay, tell me what is now red, long and chili, he will say chili, right? So remember, features, labels, data input, algorithm, training, and then finally you have the model. Now you will ask, sir, this model what you are talking about, is it a human flesh of a brain or what exactly, right? It is not. So this model, inside it, deep inside it, is a mathematical equation, right? I again repeat, the model, what you get from this training out here is nothing but it is a mathematical equation, and we will see a simple example of it, right? So remember, these four things form the base of machine learning. You can remember these four things by remembering the word FLATM. Features, labels, algorithm, train it, and the model. FLATM. If you like this word FLATM, please put down in the comments that you like this acronym. So now let us do like this. Let us switch off all this camera and all. Let us go to the computer out there, and by using first, before I start with C# programming or Python, right, by using a simple Excel, let me show you how this feature looks like, how this label looks like, how the algorithm looks like, and how that mathematical equation, that is the model, looks like. So let us do this simple demo. And just before we move to the next section, right, I want to just inform here that we have a WhatsApp group through which you can join our community, and this is a very pure C# ASP.NET WhatsApp group, where we discuss about job openings, we discuss about knowledge sharing and so on. So if you wish, you can join from this link out here, whatsapp.questpoint.com, and let us share knowledge out here. So let us continue. So now here we have a very simple data out here. We have the age and we have the premium. Okay. So for the 10 years of age, the premium is 2000. For 20, it is 2500. For 30, it is so on, right? So if we take this data and if we train our machine, so can the machine give me the premium if I give him the age? So if I say him now, let us say that I go ahead, I train the machine, I create a model out of it, right? So if I say now the age is 85, then he should actually give me the premium. So that is our goal at the end of the day, right? So in other words, as we said, that whatever is your input now becomes the feature. So age here becomes the feature and premium becomes the label. Look at it. Age becomes the feature and premium becomes the label, right? Now let us say that I'm in some 90s out there and and we didn't have any machine learning. Then how would we have achieved this, right? So the first thing I would have done out here is that I would have said that, okay, how is this data actually like? What is the trend of this data? Is it like linear? Is it like polynomial, or is it like what exactly it is, right? So if I go and if I plot this here, so if I go and if I plot this out here, and if I see this, it clearly looks to me linear, like so. Let me so what I'll do is, this is our output, I'm sorry. So I want to remove this from here and I just put everything out here, right? So if I see now, yeah, that's a perfect linear, you can see here. So as the age increases, the premium amount increases. So one thing I have confirmed here is that yes, the data is linear out here. Now you will say that, but when we are talking about large data, you can't go and plot with Excel like this, right? So at that time, how does it work, right? So we'll see that, but for now the data is linear, right? So if the data is linear, and in order to predict a linear data, we can use something called as linear regression. We will talk about regression later on, but at this moment, just remember that if you want over here now to predict the premium, the mathematical formula is linear regression, which is y equal to mx plus c. Don't go in the maths for now. Believe me, trust me, don't go too much on the maths. We will discuss on this later on. So in this y equal to mx plus c, the y is actually our premium, right? See, from the maths point of view, y is our premium and our age is the x, because age he is going to provide, right? So in other words, this y, which is in maths the y, is actually the label in the machine learning, and the x, which is the input, is the feature in machine learning, right? So these are different terminologies in different sections. So basically in different fields. So when it's machine learning, you'll be using the word feature and label. When it is maths, you will be using the word y and x, right? So fine. So y is the premium. So first thing, what is the m? The m is nothing but the slope, right? Now to calculate slope, I will use the formula of slope, which is available over here. So slope. So what is your known y? So this is my known y. What is your known x? This is my known x. So you can see here, guys, at the end of the day, I don't need to know maths. Even if I'm doing in Excel, do I have to know the formula of slope, like y2 minus y1 divided by whatever, right? I don't have to, right? I have to just use the formula. In the same way, in machine learning, you will just write the code and not get too much into the formulas, right? So we'll talk about that later on. So but for now, this is my slope. And what is my intercept? So c is my intercept, where this m stands for the slope and c stands for the intercept. So here also, if I see here, there should be some formula for intercept. So again, intercept, look at it, known y and known x. We'll just hold your horses. We'll be discussing this how we'll do in .NET, right? But for now, try to understand the process, what is involved here, to what is the process involved, to actually get to the point of that model, right? So now what is my final formula? My final formula, the final output, if I see, so y is equal to m, which is this, into, which is into what is your x? Your x is 85 plus, now I'm going to go and put this into a bracket just in case if the board mass, right, does not mess up. So y is equal to mx plus c, and this is the c. So for 85, if you see, for 85, he is saying that your value would be 19,022, which looks appropriate. For example, let me try for 80. We can do a back testing, right? So if I try 80, look at it, it is giving me 19,000 here, and here it is giving me 17,000. Now remember that this data at this moment is not truly linear. Please understand, it is not truly linear. In other words, you can see it is not like 2,000, 3,000, 4,000, 5,000. It has little bit up and down. That's why you can see it is having some kind of a small error out here, like 18,000 and 17,000 means there is a 19,000 and 17,000 means there is an error of whatever, 19,000 minus 17,860, right? And that is right. It is a prediction. It is not the thing which is, it is not that. Remember, in machine learning or any model you create, don't expect the accuracy to be 100%. It's going to be 90% up and down, and definitely then that's where you will apply some corrections or something over here, right? But if this data was linear, means if this was like this 3,000, let's say if I put it like this, 3,000 and something like this, if I had made this as linear like this example, then my value would have been perfectly right. Look at it now. If I put 80, it is giving me accurately 9,000. If I put 60, it will give me 7,000. If I put 30, now it's exactly predicting because this is exact linear. But the real world actually is not like that. Real world would be something like this. So this output is also right. We can do a testing with 30 as well. If I do a testing with 30, you can see so there is an error of something plus minus 200, okay, frankly. So what I can really do is that I can just say, okay, my error is plus minus 200. So must be, I'll say, okay, this minus this is my error, right? So now you can see here. So now let us try with 80 again. So with 80, now you can see it has actually gone. So this is So over here it's not minus, it has to be a plus now, right? So as the values go higher, it has to be, so you can see now. So what I'm saying at the end of the day is that whatever value you get, right, you need to give a thought on that, saying that, okay, this is not accurate, so what do I do for it? What is my error, right, in this? And that error or that noise you will actually try to adjust. But whatever it is, at the end of the day, what we have done, we took this data out here, right, and we took up an equation. So if you look at the steps, what were the steps we have done? First one, from the data we identified our features and labels. That is the first point. Second, this is the most important point, we went ahead and we chose linear regression. So in other words, we chose a mathematical formula. And how did we choose linear regression? Because it was showing a linear, this was showing that this is a linear data. So must be before this, we can put one more step before we do the third step. This would be a third step. So the second step is we identified the data pattern, right? And depending on the data pattern, we chose an algorithm. Right? So this third step is we chose an algorithm, and then fourth step is our model, which is nothing but the algorithm got created. See, what does a model mean? In this case, the model means y is equal to, so what is the m? 232 into x. So what is the x? Whatever is given, right, plus what is the c? It is minus 733. This is your model. This is your model. When we calculated the m and c, right, that is your model. This is your model. So at the end of the day, a model is a mathematical equation. A model is a mathematical equation. So remember this FLATM, right? So in machine learning, we have features, F, we have labels, L, we have the algorithm, right? We have the algorithm, A. Then we go ahead and we train, and after training we get something called as the model. So here when we say train, means we actually calculated this formulas out here, right? We calculated the final value, so we have the final model out here, right? So that's the process, using Excel. Now what we'll do is that if the same thing, if I have to go and do it by using C#.NET, how does it work? So now let us try to define this thing called as model, right? So look at this on the Excel. If you see, right, this was our formula, y equal to mx plus c is our formula, and this y equal to 232 into x plus the intercept, which is minus 733, right, is 733. Let me make it a little bit, yeah, this minus 733, y equal to 232 into x plus into the bracket minus 733 is our model. This is a formula, but as soon as the m and the c is calculated, the model is created. So what happens internally when we actually run the Python program, or when we run a C# program, right, or any machine learning program, what it does is it will actually go ahead and say that, okay, this is the formula, right? It will use the formula of the C, right, which is an intercept formula, right? It will use the formula of the m, right, which is actually to calculate the slope, right? And it will actually calculate this y equal to 232 into x. So that means that inside when you say a model, it is nothing but it is the calculated mathematical equation, right? So in other words, one is the mathematical equation, which is y equal to mx plus c. Look at it, I am flashing on the screen. The another one is, from that the machine learning will calculate and say y equal to 232 into x plus minus 733. This is the model. So the calculated values, right, which can bring the y, is the model. So at the end of the day, the model is a mathematical equation, irrespective you are predicting numbers, you are doing prediction of numbers, or you are doing prediction of text. It is always a mathematical equation. Now this exercise which we have done currently, the finding the connection between the age and the premium. Now hear me very carefully. So we have the age, which is 10, 20, 30, 40, right? We have the premium as per the age, 2000, right? In other words, both of them are continuous numerical values. Both of them are continuous numerical values. This process of finding the connection between two numerical values, two continuous numerical values, is termed as regression. Regression. See, remember, it's not just two continuous values, it can be multiple continuous values. For example, you will say, okay, we have the age and we also have let us say the blood pressure example, depending on the blood pressure, depending on the sugar, also the premium increases and decreases of the insurance amount, right? So that means now you have three features. For example, you have the age, you have his blood pressure, you have his sugar, and depending on that you would like to decide what is the insurance value. This also is termed as regression, only that in this case you have three features, you have three inputs, and you have one label, which is the insurance amount. But whatever it is, whenever it comes to finding the connection between to find out the connection between two numerical values, that process or that thing is termed as regression. Now remember that whenever you are referring this lectures out here, please, I would suggest to go through this document, right? You can see that here also I have the index, right? This is the index of the AI ML for C# developers, right? So if you are saying that, okay, can you tell me what is features and models? I have given a link out here, it goes out here, right? So if you see out here, a lot of Q&As I have put, what is AI ML, explain features and labels, what is pipeline, and so on. So look at this, I will just go through the definition of regression. Regression is a machine learning technique that predicts a continuous numerical values based on the input data. See, whenever we say input, which is features, and whenever we say outputs, which is labels. So now let us do like this. So we have done regression by using Excel, right? But definitely when it comes to Excel, right, I mean, like if you have millions of record, then Excel will just slow down, right? Isn't it? So definitely we now want some kind of a program, some kind of a Python program, or must be a C# program or a Java program, which will actually go and run this and actually help us to calculate this model out, which will actually help us to calculate the slope and the intercept, right? So let us go ahead and using C# and ML.NET, let us see that how we can go and do regression analysis by using this value what we have at this moment, right? So remember, using Excel, yes, it works, but when it comes to lot of values out there, if you want to do automation, and also most important, security, right? There is no security in Excel. Somebody will just copy Excel, take with you and start working on the data, right? But by putting the data into SQL Server or in RDBMS and having a C# program run over it, you have some kind of a security. So let us do a demo. We'll switch off this camera, and in that demo, let us go ahead and see that how we can do simple linear regression. Simple linear regression. This one here is a linear regression. Why? I have already said you, must be I can just draw the diagram and show you this is a simple linear regression because it is growing linearly, isn't it? So again, regression has a lot of types: linear regression, polynomial regression, and many other regression, but this one is a simple linear regression, right? So let us go ahead and see by using C#, by using ML.NET, how to implement simple linear regression. Let's switch off this camera and let us see the demo.
So first, let us understand what exactly is ML.NET. So you can see here, this is our syllabus out here. So this document, what you see out here, is not only the syllabus, but also it has Q&A. So you can see here, this is the complete syllabus out here, and also it has Q&A out here. So for example, what is AI/ML, what are features and labels? So whatever I have explained till now, you can also go and read these notes. So what is ML.NET? ML.NET is a machine learning framework by Microsoft. It is created by Microsoft that allows .NET developers to create models, train models, right, without leaving the Microsoft ecosystem, without leaving the .NET ecosystem, right? So go ahead and create a simple console application. So you can see here, you can see that I have this machine learning project out here, this simple project out here, where all the code I have written, lab 1, lab 2, lab 3, you can see here, these are all lab 1, lab 2, lab 3 out here, right? So first thing, go ahead, create a simple console application, right? Create a simple console application and from the NuGet package, use this Microsoft.ml. So on the NuGet package, you can go ahead here and search for Microsoft.ml. So we have to at least take two packages for to start with. One is Microsoft.ml, right? This one out here, and second one, so this one out here, and the second one is Microsoft.ml.components, this one. So you can see here ml.mkl components and Microsoft.ml. These two packages are needed. So as we said that the first package, the ML.NET, is nothing but that is a core framework that allows .NET developers to do machine learning inside the .NET ecosystem without using Python, without using anything. You can do it, right? Now there is also one more NuGet package which I have added, which is the MKL components. See, when we are talking about machine learning, right, machine learning has a lot of mathematical computation. Now our system.maths library, if you know that we have a system.math, that system.math library is really very slow, right? So these MKL components are nothing but they are optimized maths library. So they are actually math kernel library, MKL math kernel library, which is actually given by Intel, right? And this math kernel library has numerical computation. So if you want to do numerical computation, you will use this. Why? Because it is damn fast. So as compared to our system.math, this math kernel library is damn fast out there. So for any kind of mathematical calculations, right, we'll be falling back to MKL and not to system.math, right? So two things you need. One is ML.NET and one is MKL components. So that is the first step you need to do. Import both of these components in your project. So now let's take the same Excel data in our C# program out there, right? So we're going to go and take the same Excel data out in our C# program. Now, in order to consume this data inside ML.NET, right, we need to first create a class which has at least two properties. One is the age and one is the premium, right? So you can see here I have created a very simple insurance data class which has an age and which has a premium. And you can see that I have just created this as float. I think you don't need to have a float out here. It's the age, so you can use an int if you want, right? Premium, yes, premium has decimal, so you can use a float out here. Also, you can see that there are two annotations, or I'll say there are two attributes, you know, which I have put out here: load column 0 and load column 1. For now, keep these attributes, right? But I think, you know, for this first demo, this lab 1 demo which I'm doing now, you really don't need this, but in the further coming lectures probably will need it, right? But if you want, you can remove this and you can give a try to this lab 1 demo, right? So this is the insurance data out here, and this is the insurance data. This is a simple list which I'm returning. So this data, what you see out here, 10, 2000, 20, 2500 and 121,000, right? So 10, 2000 and 20, well, not exactly. I think I changed some data out here in the Excel. So must be I can just keep it 2500. So the same data I have taken here, 6,000, 9,000, fine. It's not exactly same, but yep, I can just make it same, 11,000, right? Fine. So this is the data out here. Must be if you want it, you can go ahead and you can change the data accordingly. So I've taken this data out here, and this data I have loaded into a collection, right? A very simple collection out here, right? So this data now we will use inside our ML.NET. Now one of the things which can come into your mind is that can't we load data from CSV files, or can't we load data from SQL Server? Absolutely you can, right? But for now, to keep the demo simple, right, I have just created a static list out here. So the first thing is, if you want to do anything in ML.NET, either you talk about loading the data, either you are talking about predicting the data or training the data, right? Anything what you need to do, right? The first thing is you need to go ahead and create the MLContext object out here. So first thing is we'll go ahead and we'll create the MLContext object, right? Now, if you see at this moment, I have created this data regression class out here. And in this data regression class, you can see this get insurance data. is where our static data is lying. Get linear insurance data, this one, get linear insurance data is where our data is, right? So now the next thing is we need to go ahead here and load this data into MLContext, right? So for that we'll say MLContext dot. So in other words, if you have any data source out there, in order to use the data source, you have to load it in the MLContext format, right? So we'll say here dot load from enumerable, right? So remember that our enumerable class is of the type, so remember our class is of the type insurance data, right? So I'll say insurance data, right? And data regression. So this is where our data is, dot get linear insurance data. So basically this is how we are loading our data here. You can see MLContext.data.load from enumerable. Now in case if you want to use SQL Server or some other thing out here, you can use the database loader out here. Look at this, there is something called as a database loader, but for now we'll just stick to enumerable. Okay, so this is our data. So look at this, the first step is I created the MLContext object. The second step is I loaded the data and I have access to that data. Now the next step is to create the pipeline, to create how this data will be loaded, how this data will be mapped, right? Remember when we started this lecture, we talked about the pipeline concept. So very quickly, if you remember, we said that we have features, we have labels, and the labels gives out the model, right? So here we now need to go and configure how is our feature, how is our label, how are the transformations, and so on. So that is the next step what we need to do. So now the next thing is, let us go ahead and write the pipeline. So remember, we have the data out here, but we need to now go ahead and write here saying that from this data, what is the feature, what is the label, which algorithm we want to use, and so on, right? So we'll say here MLContext dot transform dot concatenate dot append. The first thing if you see out here is that the MLContext follows Fluent API structure of programming. Fluent API means, just in case if you have ever done JavaScript, you will see that http.post.then.success.failure, right? So you can see the syntax is MLContext.transform.concatenate.append and so on, right? So first thing we are seeing here, MLContext, this data what you see out here, which is now in this structure, it is in this structure, age and premium. Go ahead and start transforming the data, right? And the first thing what we need to define now is, when you say that you want to transform the data, the first thing is we need to go and define features. So we'll say here that currently if you see we have just one feature at this moment. So our feature, remember, feature is the input, right? And label is the output. So age is the feature. Let us go back to our Excel sheet. Age is the feature and premium is label, right? Age is the feature and premium is label out here, right? So we'll say here age is the feature, right? Now very quickly again, I can have multiple features out here. Means, for example, you can see at this moment I just have the age as the feature, but it is very much possible I can have one more feature out here. Example, I can say that how about feature is let us say that BP level 1, so low level BP and high level BP. So depending that he has a low level BP or high level BP, his insurance amount can change, right? Look at it. So I just give a name here, BP level 1, BP level 2, right? So then what happens is the feature also is comma BP level 1, BP level 2 and so on, right? BP level 1, BP level 2, and all of these three features, we will just give one name to it and we'll say it is F1. So we are saying that what are the features? F1 is our feature which is having age, which is having BP level 1 and BP level 2. So this is how you go and define your feature. But remember, at this moment we just have one feature, which is the age. So for now I'll just keep it 1, but just in case if I had multiple features, I have to just do a comma. That's why this syntax is concatenate. That's why it says concatenate out here. So dot concatenate, take all of these features and we represent that feature with a name called as F1, or if you want you can just keep the word features, because why I would suggest to keep the name as features, because a lot of times ML.NET uses the name features as it is, right? So let us not give it F1 or F2, let us give it features out here, and for now we just have one feature, that is this, right? So that is the second part. The third part is, so we have defined our features. The third part is we have to define our label and algorithm as well, right? Now you can see dot append, and in this dot append you will see that it takes up if you look at this, if you look at this input out here, it takes up ml data dot trainer. So basically trainer means the algorithm, right? So I'll say here, okay, so the trainer is MLContext. In the regression I want to go, so MLContext dot regression, right, dot trainers, right? So it's regression is the main category. Regression is the main category, or must be, will say multi-class classification is another category, right? So these are categories of machine learning, right? But for now we are trying to find a relationship between two values, two running values. So we are saying MLContext.regression. In that, the trainer which I want to select is OLS. We'll talk about this OLS algorithm, right? So remember, this is the main category and this is the subcategory. This is the main category, MLContext.multi-classification, MLContext.regression, and in that the actual algorithm is OLS out here, right? So look at this, transforms.concatenate, define the features, we define the algorithm, and now in this OLS we have to go and we have to define our label, right? So over here we will go and we will now define our label. So in this we need to now go ahead and give two things. One is the label column name. So the label name would be here, the label name would be, the label is the output. So remember, our output is premium. Our output is premium, right? And what is our features, right? Our feature column name is features. Please understand, features, this one. And remember, as I've said, it is plural. So features at this moment is just pointing towards age, but it can also have comma BP1, BP2 and so on, right? So look at this syntax looks little bit tough, when you start doing ML.NET, right? Just have to remember that it is following the Fluent API concept out there. So while you're writing the code, ML.NET.transform.concatenate, concatenate helps you to define the features, dot append, this is the algorithm, this is the main category, and the OLS is the actual algorithm in the regression, and we are defining that the label is the premium, the output is the premium, and the input is the features, and features at this moment is pointing towards the age out there, right? And then now we can now go ahead and take this pipeline and we can now go and train it. So remember, from the pipeline training, so pipeline, so we go ahead and we say pipeline.fit, right? And what is our data? Our data we have already loaded out here. So look at this. In this pipeline we have defined the features, we have defined the labels, we have defined the algorithm, and we are passing him that data, and that goes ahead and creates our model. Remember, when you say the model means this one, it will actually go ahead, it's going to use y equal to mx plus c linear regression, right? But the values will be already be calculated, 232 into x plus minus 733, right? So that's what exactly is the model out here. Now at this moment, what I want to do is that I want to go and predict a single value. So in other words, I want to go and just give the input as 85 or input as 75, and I would like to see that what is the premium he is giving to us, right? Now in order to do a single prediction, right, if you want to go and do a single prediction out there, or if you want to do any prediction out there specifically for linear regression or any kind of regression out here, you need to create an output class as well. See, this is the input class. Get insurance data at this moment is the input class, but we also need to go ahead and create an output class as well, where we will receive the output, right, where we will receive the output. So in order to receive the output, right, we'll create one more class out here. So basically, so remember that this is the sample code I'm following out here. So we have one more class here called as insurance prediction. So look at this. So we have the insurance data out here, right? This is the class to send the data, right, to load the data. But what is the final output I want? I just want the predicted premium. I just want the predicted premium. Now remember that at this moment our output is a predicted premium, but sometimes it is not the predicted premium, it is the quality of the data. So you will say that how much errors this data has, or how much this. So that's why, you know, what the machine learning community does is that they don't name it as the predicted value or something. You know, they will say that sometimes it can be the value, sometimes it can be the quality, sometimes it can be true and false, right? So that's why they say it as a score. So whatever is your property out here, you need to go and decorate this output saying score, because machine learning understands this term called a score. Score is nothing but the output of the prediction. It can be a value, which is for now it is a value, or it can be a quality of the data or anything, right? So now what I'll do is that I will go ahead here and I will say that this is our model, and I will say model, go ahead and create a prediction engine. Look at it, create a prediction engine, and this prediction engine's input is the insurance data, and output is the output. You should put it into this prediction object out here, and the model, the brain, is what we have at the top. So look at it, we loaded the data, we created the pipeline, then we said that this pipeline will connect to this data, which is the model, right? And now we are actually creating this prediction engine. Now what we can do is we can say here p.predict, right? So what do you want to predict? I want to go and predict let us say new insurance data, and I want, can you help me to predict, if I give the age as 85, tell me what is the prediction, right? So we'll just say where p is the prediction, right? And we can just go and say here console, so slow I'm writing, p dot, and we'll say that tell us what is the predicted premium out here. So look at this, very simple lab 1 out here, right? Having the data, the pipeline, the model, the we have running the prediction. Remember, at this moment we are doing a single prediction, that's why we have created a prediction engine. But when you are doing bulk prediction, you will not be using this methodology, you will be using something else, right? So now let us go and run lab 1. So in order to run lab 1, what you can do is that, remember what I'm doing out here is, you know, I have created here week 1, week 2, week 3. So from the learning perspective, you can plan yourself saying this is in the week 1, these are the labs I'll complete. In the week 2, these are the labs I'll complete, right? So over here, if you want to run this, you can go to the main program.cs of this code out here, right? And you can say from the week 1, I want to run lab 1, right? So let us go ahead and run it, and let us see that what is the output. I have set this as startup. We can also just put a debug point out here and let us run it, right? So there it is. Let me go and debug inside it. Lab 1, simple prediction using ML.NET, and we are using the OLS engine. We'll talk about the OLS thing. What happened? It did not go in. Let me put a debug point here. I don't know what happened. So I'm going to put a debug point here. Let's run it. Yep, so there it goes. So we loaded the data, created the pipeline. We call the fit method. Fit method means we are actually training and creating the model out here. Take it as an exercise, go ahead and try to extract from the model the slope and the intercept, right? You will find the values are approximately what I have put it in the Excel out there. And we are saying I want to predict 85. So for 85, he is saying 17431. 85, he is saying 17431, which I think is quite right. Look at this. Look at the data out here. For 80, it is 16,000. So yes, from the linear perspective, from the linear data perspective, 17431 looks to be a right data, right? So you can see here he has done the prediction by using simple linear regression. Simple linear regression.
Now, definitely, this is a long lecture of 1 hour, right? And in this lecture, there are a lot of practicals also, there is a lot of theory also. And many times, you won't understand certain topics, right? So what you can do is that whenever you are asking a question in the comments down below, tag that timestamp. So for example, if you have a problem at, let us say at 11, after 11 minutes, so you can just go and type here at the rate 11.00, whatever it is, put down your problem so that, when I see your note out there, I can exactly know where the problem is. So now that we have seen the demo, right, I want to emphasize the point that model is a mathematical equation. So what we'll do is we'll do a very short demo, and this model, what you see, right, what you have seen at this moment in your code, let us try to extract the intercept and the slope from it. So if you're able to extract the intercept and slope from it, from that you will come to know that this model is nothing but a mathematical equation, right? So let us go ahead with this demo, extracting the intercept and slope from the model, and that will convince us that the model is a mathematical equation.
Okay, so you can see here all the labs. Now very quickly guys, before we proceed, right, I have made some little bit small changes on the structure to make it more simplified. If you remember in the previous lab, I have said here week 1 and week 2, I talked about it, right? I have just put all the labs into a static class called as all labs, right? Because I feel that week 1, week 2, week 3, it looks very good when I'm taking an online training, because in online training what happens is I go week wise, right? But now because this is a recorded course out here, so I just said that I will just make it all labs out here, right? And if you want to refer these labs, right, then please note that you should refer it through this document. So for example, you can see there are some theory. So in case of theory, you are just looking at the videos, but let us say now you're seeing the lab 1, the simplest ML.NET regression code. So this is what it is, lab 1, which we did in the previous section, right? So now here it is lab 2. This is where we are talking about to demonstrate that the model is a maths formula, right? And remember, when you want to execute it now, you will not say week 1 or week 2, you will just say all labs and the lab number, right? So let us go ahead and let us try to understand this code out here, and let us try to see that how a model at the end of the day is nothing but a mathematical formula. So let us understand the code of lab 2, right? So you can see this is lab 2. Let us understand the code. So till here, whatever we have talked in lab 1, the code remains same, right? Now what we want to extract is, we want to extract the intercept and the slope. That's what we want to do, right? Now remember that when it comes to machine learning, intercept and slope is termed as bias and weights. In maths it is termed as intercept and slope, but when it comes to machine learning, you will hear the words bias and weights. We'll come to that, right? So first thing, this complete thing what you see out here is termed as a pipeline, right? So you can see the way the code is ml.transform these features, these labels, the algorithm into a pipeline. So what happens is you have a pipeline wherein you have the data which is in the features and labels format, right? And this data is then fed to the algorithm, and then that algorithm is trained, and then the model is created. What I want to say is that you have series of steps in the pipeline. So over here, this line out here, this model what you see out here is nothing but this. It is series of steps. Now the actual calculation of the intercept and slope is in the final step. Please understand, it is in the final step. So what we first do is that if you look at this line of code here, right, first line of code, we are trying to get all the pipeline steps of the transformation from here. So you can see here, because the model what you see out here, right, this model what you see out here is not the final thing. It has the series of steps inside it. So what we are doing is we are saying here, give me that from that model, right, extract all the steps so that I can look at them individually, right? So this is what we have done. Now definitely our interest is in the last step. Look at it, in the last step. We are interested in the last step because that's where we have the parameter. So we are saying take from that steps, take the last step and cast it into OLS model parameters. OLS model parameters. Why? Because we have used the algorithm OLS out here. That's why we have to use the same class out here, right? Now from the last step, now we are extracting the model parameters. Look at it. This model last step dot model parameters is the parameters, and in that parameter, now to get the intercept, you just say model params dot bias, and to get the slope. Now remember the slope, right? It will be like this actually. Y is equal to m1 x1 plus m2 x2 plus m3 x3, right? So you can have multiple multiple features out there. So you can have m3 x3, but the bias, the intercept, right, will be only one. The C, what you see is only one. So you can see the intercept is not a collection, but look at the weights. These are all weights. x1 and x2, sorry, m1 and m2, I'm sorry, are all the slope out here, and that's why it's an array. That's why it is saying an array. Now we know at this moment I just have one feature out here, so that's why I'm saying weights of 0, right? I'm taking the weights of 0, and you can see down I'm displaying the intercept and the slope, right? So what we are doing out here, in short, it's summarizing. We first took out the individual steps, we took the last step, and from the last step we extracted the parameters, and we have extracted our weight and the bias, which is nothing but the intercept and the slope, right? And this is the code out here. So if we run it, I'm going to go and put a debug point, and let us go ahead and run it. And also what I've done is the same data I have fed out here in Excel. Remember, Excel also has the formula to calculate the slope. Also it has the formula to calculate the intercept, right? And what we can do is that we can go and we can check that for this data, is this value matching or not, right? So let us go ahead and check. So there it is. We have extracted now the last step. From that we extracted the parameters. From the parameters, remember, the intercept is only one, m1 x1 plus m2 x2 plus c, right? So but the slopes can be m1 m2, right? So but at this moment I just have one feature, so we are extracting only, we would have only one weight, right? And this value we are displaying it on the screen. So if you see on the screen, it is displaying me 209, which is my slope, and bias is minus 366, and you can see here 209 and minus 366. I can just put them side by side. Almost I can see that even the decimals are matching almost, right? So what I'm trying to say is that at the end of the day, this model what you're seeing out here is nothing but a mathematical equation, a pre-calculated mathematical equation.
Now before we move ahead, right, let us talk about two vocabularies, and without these two vocabularies it will be very difficult to explain the AI roadmap, right? So these two vocabularies are training and inference. They are very simple vocabularies, but you need to distinguish between them, so that you know that as a programmer, which phase you are in, right? So here is a sample code. So remember, we had this lab one, the simplest code I'm showing before you. So training, so these two are nothing but they are phases. So one is the training phase and another one is the inference phase. So training phase means when you actually give the data to the pipeline and it creates a model. You can see line number 50, it is the training phase. Inference phase means where you actually give the data and you are expecting a prediction, right? So for example, you can look at line number 55, where I'm giving him the 82 age and it is actually inferring from that 82 age. In other words, we are actually using the model out here. So you can see training means creating the model, right? And inference means actually using the model. Now definitely, you can, if you want, you can talk about 2 or 3 different kind of inferences. For example, now this one here is a single inference. In other words, I'm just giving it a single value. You can also say it's a live inference or whatever, right? Another one can be a batch inference. A batch inference means you are not giving a single value out here, but you are actually giving a collection of values. So you can see here in this, now this line 117 line number is the training phase, but you can see now here it is a batch inference. Why? Because this test data here is coming from a collection, right? So you can have a single inference, you can have, or single inference / live inference, whatever name you want to give, or you can have a batch inference. So training is when you train the model, and inference is when you're actually using a model. Now that we know both of them, right? Now let us go ahead and talk about how the whole AI roadmap looks like.
So the central point of both AI and ML is the model. Now this model can be as simple as y equal to mx plus c, like a simple mathematical equation, or it can be as complex as any LLM, which can be, example like OpenAI or Anthropic or whatever, right? So it can be as simple as a simple mathematical equation model, or it can be as complex as a large language model, right? So what we have done till now, right? To create this model, we said that we need the features and the labels. We also need the algorithm. We need to go and train and create this model, right? So this is one part of AI ML, or I will say rather this is the machine learning part of it, or this is the training part of it. This is the training part of it, or we can say the ML part of it, the machine learning part of it, right? And for this, we had used ML.NET. Now, just in case you want to import something from Python, definitely Python, with all respect, right, with all humbleness, ML.NET is good, but at the same time, Python has lots of things, which today ML.NET does not have. So if you want to use something from Python, what you can do is that from Python, right, you can create an ONNX file. So you can export a model and you can create ONNX file and you can use it in .NET, right? You can use it in .NET. So this is again one more part of it, right? Remember ONNX, right? Now this is one part, the training part, which is the training part of the machine learning. The other part is programming around the LLM, programming around the model. So when you say programming around the model, means the inference phase. Remember, this is the training phase. The other phase is the inference phase. When I say inference phase, means the phase where we query the model. Inference phase. So in case of inference phase, what things we need to do? So when you get a user input, right, the first thing definitely I would say is security. So first thing is security, right? Now when you are querying a model out there, right, you cannot just go and query the model. For example, let us say that you have ChatGPT with you, right? You can't just go and say like, okay, you can definitely go and ask any kind of questions, but there should be a context. For example, if you say, okay, I want to get the capital of India, what capital? Financial capital or the capital of India, right? So basically you need to give a context, and in order to give a good context out there, you need to use something called as RAG. You need to use something called as RAG out here, right? Second, when you are interacting with the model, you would like that your model should also interact with your tools. So for example, let us say that you have SQL server at the back end, where you have the database and everything out there. You must be having some .NET components which you have created, right? So you want that these components, or I'll say rather these tools, you'd like that it should communicate with the model. For that we have something called as MCP, Model Context Protocol, so that your model can interact with these tools. Also, one more important thing which you would like to have here is agentic AI. Agentic AI is nothing but it is a machine learning AI, or it is an AI which runs continuously. For example, let us say that you can create a AI out there, which will actually go and continuously monitor your issues of your computer, of your server, and keep fixing it, right? For this, again, definitely you need to interact with the tools, you need to interact with the model, right? So in short, if you really see, when you're talking about the complete AI ML roadmap, there are two things. One is the ML part, the machine learning part, where you actually train the model. Another one is the inference part, which is the AI part, right? Why AI I'm saying out here? Because you are programming around the model. So look at this, AI and ML, right? So first thing, when you're talking about training part, you need to learn ML.NET. I will just put one out here, right? Second thing, if you're talking about security, and where the security is termed as guardrails, right? We'll talk about guardrails in the coming topics out there. And this, I would suggest to use the Azure AI out here. Remember, Azure AI is a very important component when you're using the Microsoft stack out there, right? Second, when you're talking about the RAG and so on, I would suggest that for RAG, now remember, we'll talk about RAG later on, but very quickly, this RAG lookup and all is definitely possible out here. So in case of Microsoft, they are given in ML.NET, we have various vector lookups out there, which is given, right? And those we can definitely use it, right? We'll see this in the further coming lectures, right? For MCP, we have the Model Context Protocol NuGet package, right? This is again very easy NuGet package, which helps us to connect our model to our components out there, right? And for agentic AI, currently we have something called as a semantic kernel, right? Which again is quite useful, right? Also, not to forget, when you look at Azure AI also, right, or Azure AI ML, even the Azure AI ML is divided into two sections. So we'll see the Azure AI ML also as a part of the syllabus, right? So Azure AI, when you say, right, we are talking about the inference part, and Azure ML, when you say, you are talking about creating the model. So in case of AI also, we have these two paths out here. So in other words, when you're looking at the complete roadmap, you should look from the perspective of inference, which is AI, and second from the perspective of training, which is machine learning, right? So I'll just mark it out here. One, we have to learn ML.NET. Second, we have to learn Azure AI. We have to learn the vector, how the vectors work, right? We have to learn the MCP agents out here. We have to learn the semantic kernel, right, for agentic AI. And also there are lots of other topics out here, but these are the essential parts. So when you are actually saying that I want to start working with AI out there, you should know the Azure AI, you should know ML.NET, you should know the MCP NuGet package, you should know semantic kernel, you should know how to do lookup, you should know RAG, right? And that's what my goal is in the coming up lectures.
So now let us go ahead and look at the complete roadmap. And just in case, if you are still till here, if you are still in this 1 hour still with me, right, please put down in the comments that you are here. It just makes feel a trainer good that students are seeing the video still here. And the more we get such kind of a comments, right, the more we want to record such videos. So please encourage us by saying that, yes, Shiv, we are there here for complete 1 hour. Don't worry, go ahead, right? Okay. So here it is. Now this is the complete roadmap, and let me just run this slide out here, right? So there it is in a full blown mode. Okay. Now whatever the red colors you see, the red balloon you see out here is what you need to prepare, right? So remember, look at my mouse now. This one is the inference part. This one is the training part, right? So now you will say, sir, then how do I know that the project is inference or the project is related to training? You don't have to know actually, right? See, what I feel is that most of the AI project will be inference. Inference means there will be an LLM, and around that LLM, developers will develop applications. I think most of the projects will lie in this category. But then definitely, there would be things, where you would like to go and create your own custom model because, you want to be in your own ecosystem, because you want to be, locally available for some reason, right? Then probably this would come into picture. But I feel because, nowadays LLMs are so matured, right? Most of the projects will be at the inference level, right? So very quickly here, if you are doing a training, right, then you need to learn ML.NET, right? Now, how much Python you need to learn? Very important. Frankly, if you ask me, only, when I don't have that algorithm here, see, first thing, we cannot underestimate Python. Remember, in our syllabus out here, if you look at my syllabus, right, in this syllabus out here, right, Python, I have given separate labs. Python, I have given separate labs out here. You can see, without Python, we won't be able to do things, right? Python we need to do, and definitely whatever we learn in machine learning in C#, right, we should also try to learn in Python as well, right? So definitely we need to do PyTorch, we need to do TensorFlow, and those things are definitely there. Without that, it is difficult, right? Again, guys, remember, we are having this free lecture, right? To attend the free lecture, please go to ai.questpond.com and please book your seats out there, because in Zoom what happens is we have very limited seats. So over there I'm doing a live training, and please be there, and this complete syllabus, we can discuss there as well, right? So I'll be helping you in that 1 hour. If you register for that session, it is completely free, no strings attached, right? In that complete 1 hour, I will teach you how to do ML.NET. I will teach you how to do modeling in C#. Okay, so coming back to the main point out here. So first thing, let me again run this. Yep, right. So first thing, if you want to go and train, then you need ML.NET. Now you need Python only, when ML.NET does not have that capability, and I feel that can come, must be 10% times or 50% times, 15% times, then 15%, right? In that case, you will use the ONNX model, the ONNX structure, and you can still include into Python, into ML.NET. So remember, in Python, you can create an ONNX file and you can use that model inside .NET, right? So this is what the training part is, what you have to do. Now coming to the inference part. In the inference part, the first thing is security, guardrail. And I feel that Azure Content Safety does it's a very super thing out here. Second, for the context part, for the MCP part, for the RAG part, for the RAG part, remember, we have a nice embedding out here called the extension.ai. We'll be using that, right? Now SQL Server also has RAG, so you can look into that. But I would suggest for RAG, we should look at other databases like PG Vector and so on, right? So those are better. But yes, so this is the RAG part where you to learn extension.ai and where you have to learn SQL Server vectors, right? The next thing is MCP. MCP helps you to connect your internal tools with the LLMs, right? For that, we have a very super duper MCP NuGet package in .NET. If you want to do agentic AI, we have semantic kernel. Semantic kernel is not only for agentic AI, it is for a lot of AI things, which are happening in Microsoft, right? And also for a good architecture and decoupling, we can use this iChat client, right? So for now, guys, I'm telling you, the roadmap is all these red things out here, and all of these red things out here, I will be covering in my lectures out here, like you can see here. And so this is just the lesson 1 you can think about, or chapter 1, right? Which is of 1 hour, and slowly I'll be trying to put more videos out there on YouTube, right? Please, what I want is from everyone is that I want encouragement. So go ahead and hit the like button out here, because what happens is all of these videos takes a lot of time to prepare, right? So if I have to upload lab 2 out here or lesson 2, chapter 2 out here, that means that I need to make some efforts, right? So for those efforts, please go and hit a like button. Please put down the comments down below, and I would see that how I can put the lesson, right? And second, please attend my live training, right, which is completely free out there, which will help you to understand how to do AI/ML. So there it is. You can see now this is the complete index out here. I will not go through that because this video has become 1 hour long. Let us not try to stretch this video out here, right? And remember that one is and in this complete thing out here, if you see here just quickly, right, you can see these are the regression, and then you have auto ML, and then you have supervised learning, clustering. Then you need to also do the same labs in Python as well, right? Then you have chunking, which is very important again, right? Then you have the prompt basic, right? Prompting, how to write good prompts are also important. PyTorch and ONNX file and TensorFlow and Azure AI and checking of the data quality, right? Also there is a small project. Also the basics of Python will complete, right? And so on. I mean, like, if you're talking about starting your journey in AI ML using C#, Python and Azure AI, this is the course for you, right? And very quickly before I end the session, remember what I have said. If you go and if you share this video on your LinkedIn and if you tag us at QuestPond, right, that is, you can see that is a LinkedIn tag out there, you will get this nice ebook, which will help you while you're looking at the lectures. You can also look at the notes. So you look at AI ML lectures out there and you can see the notes out here, and this will help you to revise also very quickly out there, right? And don't forget, we have our WhatsApp group also, whatsapp.questpond.com. You can always visit, right? Okay, I know the lessons have ended, right? But the best way to know if you understand these lessons is with a small quiz. So now in the coming 4 or 5 minutes, right, I will be asking some questions, and I'm expecting that if you can give that answers in the comments down below, right? Must be you can just write one sentence, one line, but with that, it would help me to understand that this thing was really helpful. See, at the end of the day, when I look at YouTube out there, right, I really want to put contents, which will help someone to grow. But if people are just coming and seeing the content but not participating, not becoming a part of it, then I feel that as a teacher I've lost somewhere. So let me see that how many people really answer these questions, right? The questions are very simple. The questions are related to the 1 hour video, right? In the 1 hour, whatever I've taken, only I'll be asking questions around it, right? So let us start with the questions, and I'm expecting that if you can put down the answers in the comment section down below, it will not only help you to revise, but it will also help you to judge that how much you have learned in this 1 hour of video. On the screen, I'm flashing 3 columns out here. So this data is on housing data, the house and the cost of the house. So one is we have the size of the house, another one we have the location of the house, and the final one we have the cost of the house, right? Question is that what is a feature and what are the labels? So which columns here are a feature and which columns here are the label? Remember, in lesson 2 and lesson 3, we had talked about this. FLATM, features and labels, algorithm and training. Remember? On the screen, I'm flashing 2 equations out here. Y equal to mx plus c, and the second one is y is equal to 10x plus 30. Question is that from this, what do you think? Which is a model? Remember, I'll not actually speak, but let me just say, okay. And if not, then remember we have the lesson 5, which was a theory, algorithm versus model, formula versus model. You can watch that over there. I had explained one is what and one is what. Remember we said regression. Regression is nothing but if you have 2 continuous values and if you want to find a relationship between them, we have regression. On the screen, I'm flashing 3 graphs out here. What do you think? These graphs out here are linear regression or polynomial or what exactly? Please write down all of these 3 graphs represents which kind of regression data. MKL component NuGet package. Remember in lab 2, that is in lesson 7 lab 2, we had talked about MKL component NuGet package. Question is that what is the use of this NuGet package? On the screen you can see I'm flashing a code out there. My question is that what kind of inference is this? Is this inference a simple inference, a single value inference, or what do you think is this? What is it termed as, right? It is not a single value. What is the name of this kind of inference? For that, please watch lesson 9 theory where I talked about inference and training. What kind of code, what you see out there, the inference code, what you see out there, what exactly it is termed. We had discussed about a word called as ONNX. Must be, I can say, an acronym called as ONNX while we discussed about the roadmap. what exactly it is. Write down few sentences about it. Thank you very much. So hope that you enjoyed the quiz, and I'm expecting the questions to all of these 6 questions. You know what I've asked? I think I've asked almost 6 questions out there, whatever I'm flashing on the screen, just in case if the numbers go up and round, because I was speaking, I don't remember if I asked 5 questions or 6 questions. So assuming that I asked 6 questions, please put down the answers. Happy learning, happy job hunting. Thank you.